Let's say we have the function y is equal to x squared. By the power rule, we know that dy dx is equal to 2x. However, how can we use an elementary way to prove that this derivative is true? Well, recall the first principles method. The limit as h tends to 0 of f of x plus h minus f of x over h. This is an absolutely fine way of finding the derivative using the first principles method. And what you'd do is we'd say that f of x is equal to x squared, and then f of x plus h is equal to x plus h squared, and you'd substitute this in, and then you'd do some rearranging, and you'd do some cancellations, and you'd find that indeed this is 2x. But geometrically, how do we go about it? How can we think about it? Let's say we have our function, y is equal to x squared, just an approximate drawing here, and let's say we take 2 points, and we shift these 2 points towards one another, and they meet in the mean value. That forms the mean value theorem, which can be found in another video linked below. Well, we can use this mean value theorem to prove that the first principle stands correct. How? Well, let's say we take these points and we shift them towards one another. This is the same as saying the change in the 2 points over the function is the same as 0. So we have that, and we have delta x of x squared. This is what we're evaluating, our function. And how can we interpret this? We're taking the average rate of change of x squared and tending it to 0. How can we rewrite this? Well, we can go take the limit as delta x tends to 0 of x1 squared take away x0 squared divided by x1 take away x0. This is our definition still, and you're sort of confused because now we don't have to deal with this delta x, but the delta x is defined by x1 minus x0. Okay, that's pretty obvious there. That is the rate of difference, the difference between two different x values. And we can use some basic algebra to simplify this expression to the limit as delta x tends to 0 of x1 squared, sorry, that's not squared, x1 plus x0 multiplied by x1 minus x0. That is the same as the rational expression. And this on the bottom remains x1 take away x0. And we can see that these cancel each other out. And now we take the limit as delta x tends to 0 of x1 plus x0. And how do we find the derivative using this? It's actually pretty simple when you think about it. Delta x is tending to 0. We also said that 2 points are tending towards one another here. They're tending towards one another. Well, if they're tending towards one another and delta x is 0, that would mean that this thing is also 0. So x1 take away x0 is equal to 0. And then you can rearrange to find that x1 is equal to x0. And by this, we can go the limit as delta x tends to 0 is the same as the limit as x1 tends to x0 of x1 plus x0. And that simplifies to 2x1, which is equal to the derivative of f of x1, where f of x 1 is x1 squared. So that is a proof without first principles, but with a definition of using the average rate of change. You might be wondering to yourself, well, technically that is not correct in a way, because we're taking the rate of change of this and this. But really, this is the same as delta x squared, delta x. And if we were to define y to equal x squared as we did, all we'd be doing is finding delta y, delta x, and the limit as the delta x tends to 0. So that's what happens there. And we can use this theory to find a tangent line, which we will do in the next video.